Good morning, good afternoon, good evening, everybody. This is Neeraj Kumar, and today we'll talk about Azure Talk on Azure Compute on Azure Talk. And I'm joined by a couple of guest speakers who is going to help me and assist present this Azure Talk. So we have Naveen Kolipara, who's Azure Architect, who will help us with this presentation. And then we have Sakti Ranjan, who's also going to assist with a couple of demos, which we will perform during these sessions. And my name is Neeraj Kumar. I'm lead Azure architect, and I worked extensively on Azure, and I have been certified on Microsoft Azure and also on O365. I've also worked on my private cloud. So let's go ahead and get started straight away into the agenda. So in today's agenda, we're going to talk about obviously this is Azure Compute. So we'll talk about Azure virtual machines. Then we will get into Azure VM Scale Set. So VM Scale Set is where you can build identical VMs. And then finally we will talk about how to migrate from Classic to ARM portal. So the older version of the portal, Azure portal that we have. And if you have built any VMs and infrastructure in there, how do we migrate to ARM portal? And then finally we will have demo for all these sessions. So I will move on to the next slide. So what's Azure Virtual Machine, right? Many of us have worked on-prem and wherein we have created our infrastructure, and the infrastructure consisted of physical servers. So on physical servers, you will install your operating system, and then after that you will configure your configurations, like you will install IIS, you will install SQL Server, you will install all kind of application that you want on the virtual machine, on the physical machine. So then it came the virtualization phase, where we started virtualizing our physical boxes. We don't need a dedicated physical box for each of the workload that we ran, and we started with something called virtual machine on-prem. So so virtual machine is something which virtualizes the physical hardware. So now I can have multiple VMs running on one single physical box. Now the same thing, what Microsoft, when you use Azure, Azure is a public cloud, wherein all your VMs are running under the infrastructure managed and maintained by Microsoft. So you will not get to run your workload on a physical box, but you get to run your workload as a virtual machine. So virtual machine is a compute offering from Microsoft. You can say this is as a part of virtual machine, you get your vCPU, which is a virtual CPU, or compute. You get storage. We talked about storage in previous sessions, and then also when you create this VM, these virtual machines, you also need to install your operating system on top of that. So when we provision a virtual machine in Azure, not only it's just pure compute, but it brings in, you have compute, you have your VM images that that's available in Microsoft Gallery. You can also use your own VM images. You can bring your own custom image from on-prem and provision your VM using those images. And then finally, you also have to have VHD. VHD is virtual hard disk. So you need to store your operating system file. You need to store your data file. You need to store any application file that you really want to store for your application, which is running on a VM. So any virtual machine that you would create in Azure will have three components all interlinked together, which will make it a complete package and offering. You can create a virtual machine, but without VHD, without the storage, it's of no use, because you don't have any storage to store your operating system or any configuration or any applications. Similarly, you can have a VM, with a VHD, but if you don't install any operating system, it's unusable. So basically, virtual machine along with storage, along with the image that you have, makes it a complete package. Now this virtual machine is what you will, when somebody says that, hey, I'm provisioning a virtual machine in Azure, in that case, that's what you that's what you get. You get a VM with a compute and memory. Obviously, like Microsoft offers different T-shirt sizes. That based on that, based on your requirement, you will select those T-shirt sizes. You get the storage. You need to choose the storage for your VM VHDs. So this storage could be a premium storage, it could be standard storage, it could be managed disk, or it could be unmanaged disk. And we have discussed at length about storage in our in last session. So if you missed those sessions, please do refer those sessions, which is published. And and then finally you have gallery, from where we pick our Windows, Linux, or any images that you have. So this is what makes it complete. This is an infrastructure as a service offering from Microsoft. So you want to maintain your own infrastructure, you want to maintain the control over it, you want to maintain the patching, you want to maintain the code, you want to maintain the health, everything will be your responsibility. So this is an infrastructure service. Microsoft is only going to give you the compute, operating system, and storage, networking. So Microsoft will take care of this, but rest, installing the operating system, patching it, configuring it, and installing any additional software is your responsibility, because you are using you know infrastructure service. Now, so there are different kind of services that we have categorized. So you have infrastructure as a service, you have platform as a service, then you have software as a service. So the virtual machine compute is categorized as infrastructure as a service. You have other offering, which is PaaS, which from Microsoft, and then you have SaaS. But this one is categorized as infrastructure as a service. As a part of this Azure VM, as I said, you get your compute, you get your memory, and you get your VHD, and then finally you get your gallery, the images from where you will install your operating system. So before I move on, any question on virtual machine? No questions? Okay. So as a part of virtual machine creation, you also have, now Microsoft supports multiple NIC cards. So you can you have multiple NIC cards as a part of virtual machine creation. So if you are building advanced infrastructure, a kind of let's say NVA, network virtual appliance, which need to connect to two different networks, you can do that. So you can also provision a VM with multiple NIC cards, and those NIC cards could be connected to different subnets, or so that it can bridge those two networks. So you can also have multiple NIC cards. Plus, if you offer your your VM, there are different VM sizes, which gives you different IOPS, and also it gives you different throughput for your data disk or operating system disk. So we will see during the demo that we can choose different SKUs or different T-shirt sizes of VM depending on what's our requirement, and based on that you can create a VM. So Sai Karan is saying, please share a screen. So Sai, I'm already sharing my screen. If you're not able to see it, maybe you should rejoin. All right. So next, I move on to the Azure virtual machine size. This is where I said that Microsoft offers virtual machine in different variety of T-shirt sizes, and they have categorized in different series. So and these series are categorized based on what kind of CPU, memory, and IOPS. IOPS is input output for your VHD. That how much it's going to support. So IOPS is something. It's disk throughputs. You can think about that. The higher throughput that you have, the better disk performance you will get. So depending on what kind of workload you have, you will select those kind of VMs. So if it is you have a general purpose workload, which is in case of general purpose, you get balanced CPU to memory ratio. That means that your CPU and memory is equally balanced, and this is something which you will use for testing and development or small to medium databases. So different series that we have from Microsoft. So you have DSV2, which is the version 2, then D series, and A series, and AB series. This is version 2 series. So these are the series that you have available. When you select your VM size, you will get that option. The second one is compute optimized. That means if you have any workload which is compute intensive, you need a lot of CPU cycle. Which is in that case you will choose your compute optimized, and F series is what is the compute optimized series for the VM. So any application which requires high batch processing, or in application server that you have, that probably you will select your compute optimized. So in that case, you will get more vCPU as opposed to memory. So in case of general purpose, the CPU to memory ratio is equally balanced, whereas in compute optimized, you have more CPU power than memory. Then the third one is you have memory optimized, which is you have higher memory requirements. So if anything if you have relational database that will require higher memory, or any other server where you require your code to be run in main memory. A lot of some of the examples like Reddish cache is there, which is runs in the main memory. So if you have your own workload which requires higher amount of memory, you will select the G series or DS series. You can select that DS version 2. Those will work for you. Then you have storage optimized, which is optimized for storage. Any workload which requires higher throughput, disk throughput. In that case, you will select your LS series. And then finally, the two other one, which is the graphics optimized, which is NV series. It's from NVIDIA. So those are GPU. If you're doing AutoCAD and other kind of processing, you will use those. And then you have high performance computing. If you're doing any HPC workload, which requires very low latency throughput, you can use the high performance compute. It uses RDMA, which is a remote direct memory access, which is very ultra low latency access to the memory. So depending on what's your workload, you have to choose your servers and t-shirt size carefully. You have to align it closely to your objective of your workload of the server that you're running on, right? You don't want to have your web server or database server running on compute optimized. You would like to have your database server running on memory optimized, because usually the SQL server or any RDBMS is memory hungry and memory intensive. Same goes for any AutoCAD application that you're running. You will not run that on general purpose, but rather than you will get something GPU or graphics optimized work, the t-shirt size. Okay? So that's in nutshell. So Microsoft offers you these kind of workloads, the t-shirt sizes that you can choose from, and you should choose it, as per your need. So before I move on, any question on virtual machines?
Neeraj, can we? Hello.
Yeah.
Yeah, Neeraj, So can we change the VM size from any series to any other series anytime?
Yes, you can change it. There may be certain limitations, but yes, you can change the series, but that will require a downtime.
Okay.
Right.
Thank
So yeah, it sometimes, depending on what series you select and what the size, it can take from 2 to 3 minutes to resize it, or depending on. So during those time, your system will be unavailable.
Okay. Thank you.
Neeraj, is your screen is shared or not yet shared?
Yeah,
I don't see any screen presentation.
How about others? Can others see my screen?
Yeah.
We can see you, Neeraj.
Yes.
Yeah, we can see you. Yeah.
Yes, able to view.
Okay. All right, yeah, that's what I thought. Maybe it's you can rejoin, so then uh,
Yeah, sure, I'll do that.
okay, so that will. All right, let's move on to the next slide. So we have covered virtual machines, so which is like infrastructure as a service offering. Now, Microsoft has also it's called Azure VM Scale Set. So this is also built on top of infrastructure as a service (IaaS) offering from Microsoft. It utilizes Azure VM. But the scale set, as the name itself, it says it's a set of identical VMs, virtual machines. So you have your virtual machines, which you build as a normal regular part, but now you have a requirement where you need identical VM of the same configuration. So in that case, Microsoft offers you something called Azure VM Scale Set. This is an offering from Microsoft. It's free of cost. When I say it's free of cost, underlying infrastructure is infrastructure as a service and other components. So Microsoft is not charging anything for building out VM Scale Set. This service is free, but you will pay for the underlying compute charges, you will pay for underlying storage charges, you will pay for anything and everything which is required to build this VM Scale Set. So VM Scale Set is a pool of servers which is running identical CPU or identical configuration. So you can imagine that, let's say if you have a use case where you want to run a web server, and then that web server should have an identical, obviously we keep identical infrastructure for any workload that we run. In that case, you can select VM Scale Set, which will let you deploy the VM with identical SKU size, or within identical you can select A series, you can select DS series, or any series that you select, and then you can build that using VM Scale Set. So when you build the VM Scale Set, you get to group all your VMs into one bucket. So you can just think about it. And when you need to access this, Microsoft will build this VM and then front end with your load balancer, so that you can reach out, and this is purely layer 4 load balanced, and then you can build these VMs. As far as what kind of operating system is supported, Microsoft supports Windows operating system. So like if you want to run any VM scale set on Windows, you can do that. Using Windows, you can do that. If you're using Linux, you can use Linux. So both are supported. So today Microsoft supports Windows and Linux. Plus, you can also bring in your own custom images. So in case, let's say if you have any image from on-prem and you want to run that as a scale set, and something which can be brought in. So Microsoft is not restricting you to only use Microsoft publish images like Windows and Linux, but you can also bring in your own custom image. But that has to be thoroughly tested from your perspective on our side, how that will work with the scale set. So the scale set. Today, Microsoft is using Scale Set for a lot of its other features. So, for example, Microsoft is using uh, VM Scale Set for two of its services. Probably you would have used that in your production environment, if you would have uses. One is Azure Container Services. So like if you build any container service in Microsoft today, Microsoft Azure, in the background it will create a scale set. It's an identical VM, and then on top of that it will host the Azure Container Services, which is basically, and then it uses Docker to orchestrate it, or you can use Kubernetes. So behind the scene, the Azure Scale Set is what is used for Docker. The second service which is which uses a Scale Set is your Service Fabric. I don't know how many of you are aware, but we are going to cover about the container and Azure Service Fabric in next session. But Azure Service Fabric is a platform which lets you host your microservice-oriented applications. So you can build your microservices and host this on Azure Service Fabric platform. So when you build that Azure Service Fabric platform, that's again makes use of scale sets. So it will build a pool of identical VMs, and it will dynamically scale dynamically scale out and dynamically scale in. So it will basically, if there is higher CPU utilization, it will spin up another VM of same size. So Microsoft is already using this for some of the services it is offering, and it's used by other services also. As I said, you have Azure Container Service and you have Azure Service Fabric. These are the two. On top of that, you can also build your own, VM scale set depending on what's your use cases. So when we create in scale set, what you all get? So you get your VMs, you get your network. Obviously, without network, these VMs is not going to talk to each other. You also get an Azure load balancer and application gateway. If you want, you can decide between what you need between the both. So if you need a layer 4, you will go with Azure load balancer, and if you go, if you want layer 7, you can go with application gateway. So if it is an HTTP workload, probably you will require an application gateway, which will load balance the HTTP traffic or HTTPS traffic for you. If it is anything other than HTTPS, in that case, you will go with Azure load balancer. So by default, Azure load balancer is what is you get provision bed, but you can customize. This scale set can be deployed through Azure portal, or you can also use JSON script to have your own custom scale set with different properties. Microsoft offers you both kind of options, and you can deploy your VM scale set accordingly. And these scale sets are dynamically auto scalable, so that means you can set your configuration. It's on the same line. Probably if you have used web app, so Azure Web App offers you auto scaling, wherein depending on CPU utilization, memory, and RAM and queuing length, it will auto scale. On the same line, Microsoft is also offering, if you use VM scale set, you can set auto scaling. You can say that my CPU utilization is 75%. Please spin up another instance. If it is less than 25%, please bring down one instance, and all those settings can be configured on the portal or through the through JSON script. And we will see that in the demo that will configure auto scaling quickly. All right, so before I move on, any question on the VM scale set? Okay.
So these use cases will be only on Docker when we are going to create only Docker kind of use cases, or any other use cases are there for this VM skill set?
So okay, so probably I didn't clarify it clearly. These VM skill sets are used by Microsoft. So when you use the container services, it is used, is the behind the scene, the technology is VM skill set, but that's only used by Microsoft. And that doesn't restrict you. You can create your own VM skill set. For example, IIS form, an RDP form, anything and everything that you have which will require identical workload. So you can have your own VM skill sets. So you don't need to.
For example, if I have my custom image which needs to be deployed multiple 10 VMs or something like that, so during the time I can use my custom image with the auto scale option, VM scale set option, so that it will be deployed 10 VMs as per my requirement, right?
Correct. That's right.
Okay.
So these are the two services which Microsoft is offering you, which is using VM scale set. But you have your own configuration. You can bring your own configuration, bring in your own code and VHD and anything that you want. You can bring in your custom images.
Oh, two services means Docker and Azure Service Fabric. That's what you all mentioned, right?
Yeah, that's used by Microsoft. So
Microsoft. That's used by Microsoft. Yeah. Okay.
All right, so I think there was a question about, I think Rajan has answered that. So you have scale in and scale out. Scale in is, scale out is when you increase the number of instances. That's a horizontal scaling. Scale out. So you're horizontally increasing the number, and whereas scale in is we're horizontally decreasing the number. So like if you had 2 instances and then you went from 2 to 3, that's scale out. And when you have 3 instances, you come back to 2 instances, that's scale in. That's have scale out, scale in, and then you have scale up and scale down. Scale up is where you increase the capacity. So let's say if I had 4 vCPU and I went from 4 vCPU to 8 vCPU, that's a vertical scaling. That's called scale up. And then if I come back from 8 vCPU to if I come back from 8 vCPU to like 4 vCPU, that's called scale down. So one is vertical scaling, scale up and scale down is vertical, and scale in and scale out is horizontal. And it's always wise to build your solution with scale out, not with scale up and scale down, because scale up and scale down requires downtime. Whereas in
Okay, thank you.
Mhm.
Yeah, thank you.
So let's move on to the next slide. We'll quickly touch upon migration from classic. Sorry, if you're not speaking, please put yourself on mute. I appreciate that. Thank you. So Microsoft, Microsoft Azure started way back in in 2011. That's when it started, and it was originally Windows Azure. In 2014, around that time, the Microsoft changed the name to from Windows Azure to Microsoft Azure, because it's no more Windows. Just you can have all the services as well. So prior to 2014, when Microsoft hosted this in Azure, they had two portals basically. Prior to 2014, you have classic portal, which is called ASM, Azure Service Manager. So if you were early adopters of Azure, you would have probably created your VMs in classic portal. In fact, Microsoft did let you create those VMs up to 2017 March or so, and then they stopped. Then after that, probably you cannot create it. And Microsoft is discouraging you to create any infrastructure in Azure Classic or Azure Service Manager. So the new offering what Microsoft brought in 2014 is called ARM, Azure Resource Manager. So the difference between ASM and ARM is in ASM everything was a service. So it was clubbed into one service. So you can say a VM is a service, but underlying the VM service, you have storage, you have NIC card, you have public IP, you have private IP. All these components come in together and give you a service. That didn't give us the granularity of let's say if I have one NIC card, I want to move that NIC card from one VM to another VM. That was not possible because it was all clubbed together. So what Azure RM what did is they went away from service oriented approach to resource oriented approach. So now everything is a resource. You have your public IP as a resource, you have your NIC card as a resource, you have your private IP as a resource, you have compute as a resource, and all this can be put in together to create it gives you more granular control, and it also helps you to bring in all the resources together to create your own services. So that's the beauty of the ARM template is. In case of Classic, service was already predefined. You couldn't create really your own service, whereas in case of ARM, you can create your own service. Plus, Microsoft also started supporting resource group RG in ARM portal, so you can bring all your resources. Let's say I can have two VMs, two database, two IIS VM, two database VM, two application VM, and a couple of web app servers, and all those put into under one resource group. And I can take that resource group and make it as a template, and I can deploy that as a one resource as a part of deployment. So I can have my JSON script for that resource group, and I can deploy it, and that's a repeatable process. That was something which was not possible in ASM because ASM didn't support resource group. So if you have any workload which is running in Azure Service Manager in the classic portal, and you want to migrate to ARM because Microsoft is encouraging everybody to do that, you can do that. And Microsoft offers you the scripted way to do it, and there are a lot of supports. In fact, Shakti is going to give us demo and how to migrate a VM from ASM to ARM portal. If you are a new customer, relatively new customer, and you don't have any infrastructure in ASM, then you're lucky. You don't have to go through this exercise. But if you had that, then probably you will have to upgrade. You'll have to migrate your from ASM to ARM. So ASM is also called Classic Portal or Version 1 Portal. ARM, which is Azure Resource Manager, is also called Version 2 Portal or ARM Portal. So depending on how you hear, so you can hear Classic, you can hear Version 1, you can hear ASM. So whoever you talk to, so all allude to one portal. So you have classic portal, and then you have ARM portal. So in terms of migration, obviously any migration that you take up, you have to plan for your strategy, right? So you want to plan how many VMs I want to migrate, how many storage account, and what are the networks, what are the workload, and you will start with the lab environment first. So you plan your workload. You have identified your workload. You set up a lab, and from there you do a testing, because if you want to do anything in production, and if something goes wrong, your production has gone for toss. So you really don't want to do that, right? So first you will plan, you will create a lab, you will create ASM from there, and then you will try to migrate in actual migration. You will do in the lab, and then finally, once you have migrated, you validated, verified your POC, you have done the testing, and you realize that yeah, this is the right approach that is what we should be taking. Then you move beyond migration. So beyond migration is then you perform the actual migration of your workload. So anything that you do, obviously you will have to go through a cyclic process wherein you validate your findings. So let's say I have done my lab test. I make sure that I validate those testing against the existing infrastructure or against the lab infrastructure that I build. I make sure that I run and rerun and validate that it's working. Once that validation is done and you're confident of moving ahead, then you start preparing. So this preparing could mean that you come in production and you start in batches. You start migrating in batches. So let's say if you have 100 VMs, you will start with a batch of 20 each, so that you impact only 20. And then during those migration time, you will have some downtime. So you prepare for that. Once you have prepared, you just check your readiness and your ability to move these servers. And if you see that you're ready, you can commit and move ahead. If not, then abort it, come back, and replan. So this is like typical cycle that you will probably perform when you're moving from classic to ARM. Also, you have migration workflow. So some of the migrations which are supported, you can migrate your virtual machine, which is not in a virtual network, that is supported. You can also support, it supports virtual machine migration, which is in a virtual network. So basically it will support your virtual machine migration in a nutshell. It supports your storage account migration. So if you had any storage account in Classic, you will migrate that, because when you move these VMs, you also need to move the storage account, because the VHD is in those storage account. Apart from that, any other resources that you had, like network security group, which is a virtual firewall from Microsoft, you can migrate that. If you have configured any custom routing table for your route configuration in Azure, you can do that. If you have created configured any reserved IP, like public reserved IP, in those cases, you can migrate that. So your migration will consist of the 4 sections. So you will have your reserved IP, NSGs, and we talked about. You will have your VNets that we talked about. You will also this will also encompass your storage account, and then finally you also have your compute. So these are the supported scenarios for classic to ARM portal.
Neeraj,
Yeah.
what is the recover procedure? So if you want to start the migrate, if you want to revert back it, so how can you track the logs? What exactly happened when you migrate from Classic to ARM?
So in terms of log, Microsoft offers, obviously you'll have to monitor. This migration which is happening is via script. Right. So when you run the script, you can run the script with the debug mode, and you can turn on the debugging, so which will give you much more details and errors, while it is performing those. So that's one way. Apart from that, you can also look at, if you're in ARM portal, you can look at Azure activity log and see whether your storage account got created. You can track that, whether the virtual network has been created in Azure activity logs, and you can look at any resources that gets created in ARM portal. You can track in the activity log there. So these are the 2 logs that probably you will look at, and you will also watch for any error message.
All right. So how can we revert it if in case it's not properly migrated? So I have some issue after migration. So how can I revert back the procedure to classic? We can revert the ARM workloads to classic if in case any challenges we face.
Yes, sure.
Neeraj, I will cover this. I will cover this.
Yeah, go ahead, sir.
Not now. During demo, I will cover.
Okay. So yeah, so I think, as a part of this migration, you can revert back. When I say revert back, all these are getting copied. You don't delete the source one. So, you create this replica, and then if you find that it's working in your ARM portal, then you delete your classic one. If you see that, it's not working as expected in ARM portal, then, you maintain your classic versions. So that could be one of scenario.
All right. So can we do the lift and shift on this classic to ARM rather than the migration?
What do you mean by lift and shift?
I want to move my workload which is running in the classic. I just move it.
Yeah, so you will have identical copy. Those VMs, I think, has to be shut down if I'm not mistaken, because when you copy the VHD, those VMs have to be shut down and move into the ARM portal. So you will have two copies of VHDs, one in the classic, one in the ARM. And if you want, you can retain the classic one. If you want, you can just go ahead and delete it.
All right. So how about the licenses? If I use the existing license in a classic portal, if I'm going to move the licenses to the ARM portal, that will be the work, or else that will be notified to the Microsoft support team.
So Microsoft, offers nowadays, they're offering assurance, classic assurance, wherein you bring your own license. If you have not brought in, you create the VM. That VM itself includes the licensing hourly charges for you. So if you have not,
it's hourly charges or minutes?
I don't know about the compute. Yeah, it may be minute, but whatever charges, hourly, or I think it's hourly for compute, if I'm not mistaken.
Yeah, hi Neeraj, Prayers here. So just now somewhere I have read it that Microsoft had gone with the minute charging, the way the GCP is working.
Okay.
Yeah, they have changed for 2 months ago. The AWS is running with a hourly
one.
Okay.
This one is metering is running in the minutes. So and then Prayesh, I just finish it off. Then you can raise your question. So how can you measure? So if I want to migrate the workloads from classic to ARM, what is the smoke test, or else how can you measure if I want to transfer 500 gig to ARM? So what is the timeline I can get it?
So I think, that's a very good question about the performance testing, right? That's when you perform this smoke test in lab test. You don't do the production. Right. So you set up your lab and you see the performance, you see the easy copies that probably we will use to transfer the VHD, and you will use the script to create these VMs, pre-create these VMs. So you will have to do that lab test, and you can do that. So that's why you have playground. You have your own playground in lab test. You will not do this in production. So you can use those when you set up your lab and do those smoke tests and performance tests and all the stuff. Right.
But lab test is fine. But if you go for a production, we have to give a timeline. What is the time frame the migration will be completed, right? So
that lab test will tell you, right? So let's say if I have a VM with the VHD size of, let's say, 500 gig, and if I do a transfer, you can extrapolate that number for your production.
Okay, that depends on the network traffic as well. So if you work with the multiple NICs, then anyway, so I will check on the lab. No problem.
All right, so let's move on to the demo section.
Can you hear me?
Yeah.
This is Naveen. I just wanted to add a bit here.
Sure.
So when you would like to do that part of the migration to figure out what is the timeline around each VM, one is you need to identify what kind of data that you are transferring. Then you need to do test that. I understand, you might not be able to do the production specific you can't if you are unable to replicate the production data into a test environment, then you would need to generate an equal amount of data size hard disk, test the migration, calculate the time, and add some buffer to it. That's one way. And the performance also depends on the storage account performance, how many VHDs you already have in the destination storage account and also in the source storage account. Because IOPS will also be a limitation when talking about migrating VHDs between different storage accounts.
Yeah, that's a good point. I mean, you'll have to recreate your lab as close as possible to production.
Hi, this is Uday. I just want to share my experience and answer to that question, which the 500 GB of data. Say I wanted to transfer to ARM. We have the two phases, right? Prepare, validate, prepare, and commit, right? The validate and prepare will give you the time frame. Generally, say in my workloads, I have done a storage of say VHDs with 40 TB within half an hours of time. That's my observation, and some of the observation in my new subscription, which took more than 2 hours, which add 1 TB of SSD as well as 1 TB of VHD, which closely more than 200 TB of data. So that's my observation. So when we're doing a ARM migration, I don't think so. It's a performance issue, or we should validate. I would be more concentrating on the prerequisites, because since we done a lot of migration from classic to ARM, the way we did, we generally do the validation to make sure that network, the VNets and NSG's core, and the other parameters which are meeting our the validation. Post that, we generally prepare and keep it. So because during the preparation we used to get a gateway kind of
Okay.
issues. The gateway kind of issues, that's my preparation we used to do during a production migration. I generally take 3 hours. Within 3 hours of time, I did a migration of 300 VMs. Yeah, migration. So
Hey,
yeah.
that's a very good use case, probably because most of us, honestly speaking, I haven't done any kind of classic to ARM migration. Maybe it's my work scope didn't allow, but thanks for sharing your, actual experience. So maybe, Uday, that helps to answer your question.
Yeah. Thanks, guys.
And yeah, so I'd like to give one more information. Since this, if anyone going to do now the migration where they have the express route or the site-to-site coexistence, better to the recent announcement they did. Better to delete the S2S connection and do the migration. That will going to be a smoother migration, and they did a lot of improvements in the backend, which Microsoft, based on our customer analysis, with the storage queue and the storage threshold. Because when we talking about the storage, the where the VHDs resides, we used to get a lot of issues like a threshold limit has been exceeded. That's the observation when the just in time the code has been modified. Microsoft did, and which helped us immediately to migrate closely 40 VMs. Uh, that's what I have observed. Since I have migrated like closely at 10 subscriptions with 1,000 VMs, I have seen a lot of issues from a day one. We are the one who initiated the first migration of ASM to ARM. Yeah, so that's what I just want to share. Yeah.
Thanks, Uday. So, thanks for sharing your experience. It's really helpful for audience on this call as well because we have somebody who has really done it hands-on.